Another linear modelling example. This time we have to work out an equation which would represent the cost of a bus fare if you knew the distance that the bus was travelling. So the first job is to plot the data on a scatter plot. So we're going to put distances along the bottom of the graph, and we're going to put fares up the side. So those distances have to go up, it looks like, to a maximum of about 200. So looking at the biggest number there, the distance is nearly 200. So I'll go up 1, 2, 3, 4, 5 squares is 50. 1, 2, 3, 4, 100. 1, 2, 3, 4, 150. 200 fits in beautifully. Is our distance. Right, the side I'm going to put fare in dollars. These seem to have to go up to 36, so I guess if 2 squares is equal to 10, 1 square equals 5, 10, 20, 30, 40, that fits nice. Now, let's put the data on the graph. Each one has a little data point, so 72.20 is on the graph. 178.36 is on the graph. 178 and 36 is going to be somewhere there. Okay, I'm going to plot these points and be back in a second. You might like to plot the rest of the points too. So we're done there. Next step is to rule the best straight line we can through the points, which tries to minimise the total distance that all the points are away from the line. Now that's quite tricky, especially if you haven't got a see-through ruler. I'm just going to put it through as best I can. Now, the line you put through need not go through the first point and last point. It need not go through any of your points, as long as you think it best fits through the data, minimising the distance that points are away from the line. Now, the next step is to find 2 points that are on that line. Again, they need not be data points. They could just be points that you've taken from the graph. I'm just going to take 2 points that seem to be on the graph. I'm going to take a point here, try and keep them a distance apart. So this looks like the point, well, 143, let's say. 143.30 is a point which is on my line, and another point which is on my line is here, the point 27. X equals 20, y equals 7 is on the graph. Now that I've found those 2 points, I can work out the equation of the line between them. Firstly, work out the gradient using the formula rise over run, or y2 minus y1 over x2 minus x1. And in this case, well, let's call this point our xy coordinates number 1. And this point our xy coordinates number 2. So it's going to be 30 minus 7 over 143 minus 20. So 30 minus 7 is 23 over 143 minus 20, 123. Time to go for the calculator. (23) divided by 123. (0.187). Notice I've got a positive value. I'm very pleased about that because my line has got a positive gradient. Once you've found the gradient, you can work out the equation of your line using the formula y minus y1 equals ax minus x1. So it's y minus, and our y1 value was 7, equals gradient 0.187, x minus our x1 value was 20. Okay, I'll multiply the brackets out on this side first. Y minus 7 equals, and the 0.187 times x is 0.187x, and the 0.187 times negative 20, it's already on the screen, so that's good, times by 20 is equal to negative, because we had positive times a negative, negative 3.74. That's just about what I want, only it's best to have lines written in the form y equals ax plus b. So I'm going to need to add 7 to both sides of this equation. So that means y equals 0.187x, and what I need is negative 3.74 plus 7. 3.26. That's the equation of this line, and that line describes the relationship between distance and fare. On the y-axis we had fare, so you could write like this: fare, or f for fare, equals 0.187, and on the x-axis we had distance, d for distance. This equation would represent the relationship between the two variables. These values here, the significance of these values is quite interesting. The 3.26, of course, is the y-intercept. If you extend this graph on, you don't have to go very far. It will go through the y-axis at 3.26, but what it actually represents is the fare is $3.26 even for no kilometres. It looks like they've kind of got a set fee they charge, 3.26 plus something which is based roughly upon the distance which is travelled. This number here, the 1.87d, represents the amount charged per kilometre. It's the gradient of the graph, so it's the amount of fare per distance, in this case per kilometre. Cost of a journey of distance 0 kilometres. Let's just move up again. No, it's not coming up. That's better. And this one is the amount charged per unit distance travelled, or per kilometre travelled. Okay, that'll do us.